In this second video, we will continue our discussion of time value of money and look at some different examples. We'll look at some future value examples and some present value examples. So present value is the current dollar value of some future amount. Essentially, it's asking you a question, right? What is this thing worth in today's money? This is really a good valuation question. You expect to get some money in the future, and you would like to know, if I could get that money in today's dollars, what would it be worth? And of course, that then gives you a benchmark of what the most is that you'd want to pay for this. Now, this process is called discounting. It's the process of finding present values, right? Now, the rate we're going to use, the interest rate we're going to use, has many different synonyms, if you will. It could be discount rate, opportunity cost, cost of capital, required returns, growth rate, inflation. All of these things could be incorporated or could be presented as what the growth rate is that we're talking about. So for present value, again, we know what the variables look like. Here's the formulas that we can find. Again, we can use this formula to ultimately find out the present value of something, but you can see that we can also incorporate the compounding frequency. There is an Excel formula that we could utilize if we want to actually do the formula in Excel. But of course, there is a worksheet that's provided that will help you work through these problems. So Janet Truesaver is expecting to receive $2,000 in 5 years. Her opportunity cost is 10%. So what is the value of that $2,000 in today's money? So again, you plug in the $2,000 as the future value. Interest rate's 10%. Time value is 5. And the present value of that is $1,241.84. So that $2,000 is worth $1,241. Or $2,000 in 5 years at this opportunity cost could buy $1,241 today. So the value of the dollar is losing its ability to buy things over time. What if we were to calculate interest quarterly? What if it was quarterly compounded? All we would need to do is change this frequency number from a 1 to 4. And if you're following in the notes, you know that the value of that down below here in the note section is $1,220. So example 2 is going to just another example. Let's say your company tells you, or you're going to receive an inheritance of $100,000 in 20 years. If inflation is 2%, what is the value of this in today's money? So in other words, what will $100,000 in 20 years buy if it was in today's money? So now we incorporate what? 100,000 is the future value. The interest rate is inflation of 2.5%. 1 is the compounding frequency, and the present value of this is $61,027. Now it's going to show up in the solutions as a negative number. Remember that in those solutions, the present values in the worksheet are always designated as a negative number. What would happen if inflation increased from 2.5% to 4.5%? Well, you would then just have to adjust the annual interest rate here, the growth rate, change it to 4.5%, and of course you're going to find a decline in value because inflation's rising. So then the value would only be $41,464. So now let's switch gears and think about annuities. Annuity cash flow stream, if you remember, is an equal periodic cash flow for a certain period of times. They could either be inflows or outflows, right? You could be receiving equal amounts or you could be paying equal amounts. Now we have two different forms of this, if you will, and really it just designates when the cash flows occur. An ordinary or a deferred annuity is an annuity in which the cash flow occurs at the end of each period. An annuity due is an annuity for which the cash flow occurs at the beginning. And the annuity due will always have a greater amount in the future than an ordinary annuity because interest is compounded for an additional period. So here we have an annuity due. At time zero, today you're going to make the first payment. And this is how you'll recognize an annuity due. It will say you're going to make a $5,000 payment beginning today. If it doesn't say anything, the assumption is the calculation assumptions in financial calculators and in Excel is that it's a cash flow that occurs at the end of the year. That's just the way it works. So here we have $5,000 is invested every year for the next 5 years. So that's 5 cash flows. Annuity due has 5 cash flows, but of course they don't start until doesn't make till the end of this period. So if you notice, all of these cash flows in the middle in the box here, they're all identical. So they will not have an influence to make one cash flow stream bigger or smaller. They're all the same. But this cash flow stream has 5 years to grow. This cash flow stream is invested the last day, so it doesn't grow at all. So an annuity due will grow to a greater amount because it has an extra one cash flow that actually will compound from the day of the original investment. So the formulas, as you see for these annuity cash flow streams, start to become a little bit complicated, a little bit tougher to do with a calculator. Financial calculators and the Excel, obviously, they make this type of a calculation very simple. So here we have Fred saves a lot, wants to figure out how much money he'll have if he invests $2,000 a year at the end of each year for 10 years, compounded annually, and he can earn 12%. So here we have our cash flows. If I look at our spreadsheet, we make it just a wee little bit bigger so it's a little easier to see. 12% is the interest. The time frame is 10 years. Annual compounding, you're told. Now we have a payment box. And in this payment, you have to put the $2,000. But since he's investing it, you invest a negative $2,000. So this $2,000 investment each year for 10 years, that's $20,000 investment overall is going to grow to $35,097. Right? What if you wanted to ask the question about monthly payments? We're making $2,000 payments per year. So if you divided that by 12, you would make $166.67 a month. You need to change the payment to reflect monthly payments, but you also need to change the compounding frequency from 1 to 12. You don't have to do anything else, that's all you need to do. So if you do that, then you will see what the value is. It will be a greater value because we are starting with although the payment is very small, it's going to start compounding every single month. So if you started to invest $5,000 at the end of each year into an IRA, and you could earn 10% on your money, how much would that be at the end of 40 years? Well, the answer when you plug that in here is, again, the future value and present value, we don't need those numbers. Interest rate is 10, time in years is 40, compounding frequency, we'll start with once per year. the payment, negative $5,000, that will actually grow to $2.2 million. If you did it in monthly, how would you fix that? Change the payment to a monthly payment, 5,000 divided by 12, and then change the compounding frequency to 12. That would actually grow to 2.6 million. So you get an extra $400,000 by investing monthly rather than annually. So there are a lot of examples, a lot of questions that we can ask in this. So how about this question? Let's say we just graduated, right? And we have so many bills we can't invest in anything. What will it cost? What if we took this investment and said, look, for 40 years, I need this money at the end of 40 years, but I'm not going to make any payments at all for the first 5 years. That means I'm only going to make 35 years of payments. How much will I have at the end of the time frame? So if you just change the N to 35, a 35-year investment, right, it will total 1.5 million. So 2.63 million on monthly basis, monthly compounding, minus the 1.58. By delaying 5 years, by offsetting or not paying $25,000, that's going to cost you $1 million. Seems to me we need to figure out a way to invest something as soon as we can start investing. Another question then, just looking at the same kind of problem, is what do we do with an annuity due? So there is a formula, obviously it's a different formula, right? So now we're looking for words, right? Beginning of the year. So here's this example. Again, the same example, that $5,000, if you had the beginning of the year for 40 years, that would be $2.4 million. And again, if you remember from the previous slide, it was $2.2 million. Monthly compounding, in the previous slide, it was $2.63 million. Here, monthly compounding, $2.65 million. So again, when you invest the money, it won't have an influence on how quickly it grows and the amount to which it will grow. What about finding the present value of an ordinary annuity? Now we're going to bring money back in time. Again, we have a formula. You can obviously see those formulas. You'll see that each time here. And there is obviously an Excel formula. The present value of these numbers. Again, payment is going to be incorporated. That's part of the value. And again, if you're not talking about a future value, the future value here ultimately will be 0. So here's a question. The thrift company is considering an investment that's going to pay the company $35,000 a year at the end of the year for the next 10 years. So they're going to receive $350,000 in total. On this low risk investment, they can earn 4.79%. So what's the value of this cash flow in today's value dollars? Essentially, this is asking, what's the most you'd be willing to pay to get this cash flow stream? So plugging the numbers, 4.79 is the interest, 10%, 10 years. Compounding is once per year. Now we're going to receive $35,000, so this is a positive number. That gives us a present value of an annuity of $273,000. So that's the value, that's the most you'd be willing to pay to get $35,000 a year for 10 years. Again, another example of this, obviously, you need to receive $25,000 a month during retirement, and you're going to live in retirement for 30 years. You can earn 8% on your money. How much money will you need to have in your retirement account to live for 30 years and withdraw $25,000 a month? So we plug this in, right? The interest rate is 8%. The time frame is 30 years. Now we're doing this monthly. right? So you need to have a compounding frequency of 12. It's an ordinary annuity, so you have to put in yes for ordinary annuity. And then the payment, again, you're going to receive $25,000. So how much will you need to have, how much do you need to save between now and then in order to acquire this cash flow stream during retirement? And that answer is $3.4 million. So again, you plug those numbers in, make sure you can get those numbers to come out in the cash in the solutions when you plug those numbers into the formulas. Again, we have another formula that represents the annuity due. Again, it is a complicated formula. Again, to change the old formula in Excel, you change the type. So type 1 cash flows are beginning of the year. And if you leave that blank or you make it 0, then that is a beginning or the end of the year question. So again, the exact same question. What will you have to save if you want to withdraw these with a present value of annuity due? And the answer here, $3.429 million. Again, compared to the other question, let me zip up here real quick, was 3.47. So you'd have to have a little bit more because you're starting the investment, you're starting the withdrawals a little bit sooner. Again, that's the end of part 2, and we will conclude with some special questions and some special applications in the final video.